Hey everyone, this is Professor Chan. I'm taking over for Mrs. Brown for Math 1250. I'm going to upload some videos to help you with 7.5 to 7.7. Okay, so 7.7, I want to kind of go over this. This is about vectors. And there's some basic formulas we want to talk about, okay, which is what's called dot product, among other things. Okay, so let's talk about this. Dot product is, if I look at the formula here, it looks like the following here, v times 2. And the idea is you're just multiplying your x and y coordinates, or sorry, your x and y portions of your vectors. Okay, and your result will always be scalar, right? So it'll just be a number. There's no like I plus j. It's always in a form. It's always just in a number by itself. Okay. So I'm going to show you some examples here. And remember, if you have questions, feel free to send me an email. Also, feel free to do a Zoom chat appointment with me. Okay, so let's take a look at this here. Okay, so if I'm being asked to do v dot w here, okay, all I have to do, just remember my coefficients here is 1 for both of them. So if I do v dot w, this is going to be a1 times a2, or my coefficients for my i's. So it's going to be 1 times 1. And then this one here is negative 1 times 1. So this will be 1 minus 1, and my scalar is going to be 0. Okay. Okay, let's do another example here. So if I do dot product between these two, I'll do the following, which is 3 times 4 plus negative 4 times negative 12. And my scalar is going to be 60. Okay, so that's how you do dot product. Should be pretty straightforward for most of you guys. Okay, but if you have questions, feel free to email me or arrange a Zoom chat. Okay, so let's look at an example here. Okay, there's some particular properties. Okay, so remember, dot product is commutative, right? Which means it doesn't matter the order. Okay, and it's also distributive as well. Okay, look over that in your textbook. But yeah. Okay, so the second type of problem that we're going to talk about is if I'm being asked to find an angle between two vectors. Okay, I'm going to do, you can kind of see that my problems are actually kind of the same, so I'll just use the same two as well. So and I just follow the following: cosine theta equals u dot v over the magnitude of u times the magnitude of v. And just remember, when we say magnitude, okay, we are essentially finding the distance of that coordinate. Okay, so I'm just going to do v dot w. Right, so formula is really v dot w over the magnitude of each one multiplied. Okay. So if it helps us, we're going to find the magnitude of each one. Remember, the magnitude for your vectors, it's very similar to Pythagorean theorem. Okay, so you're going to square your x component and then your y component and then take the square root. So this becomes square root of 2. And then the magnitude of w is equal to 1 square plus 1 square equals square root of 2. So when I do dot product here, okay, so we actually did the dot product, I think it was 0. Yeah, it was. But let's just do it again. So remember for this one here, I'm going to do 1 times 1 plus -1 times 1. So this is 0 all over square root of 2 times square root of 2 equals 0 over 2, which is 0. So just remember, cosine of theta is equal to all of that. So all we're going to do is we are going to do the cosine inverse. Now you guys should realize, right, what is theta such that it is 0, okay? Now, you need to be really careful. Make sure you do it based on whether it's radians or degrees, okay? Most of the times they'll ask you for radians. Other times they'll ask you for degrees, okay? But I can do second cosine of 0. Okay, that's 1.57, which actually is just pi over 2. Okay, or, right, if you're doing in degrees, it'll be 90 degrees. Okay, and just remember, if you want to change your mode, go to the mode, and you can go from radians to degrees and vice versa. Just make sure you follow what they're asking you. Okay, and get 90 as well. Okay. Okay. Let's look at number 4, or this one here. So I'm going to do the following here. Same thing. It's going to be v dot w over the magnitude of v times the magnitude of w. So v dot w is going to be the following, okay? Or sorry, let's do the magnitude of each one first. So magnitude of v is square root 3 square plus 4 square. It's going to be 5. The magnitude of w is equal to square root of -6 square plus -8 square. Equals 10, okay? So this bottom part is 10 times 5. And the magnitude, sorry, if I do dot product, so v dot w is equal to 3 times -6 plus 4 times -8. So I get -18 minus 32, that's -50. Okay, so this is going to become -1. So cosine of theta is equal to -1. I'll do the cosine inverse, although we should realize what that will be. But just remember, you can do it in your calculator. That's 180, right? Or pi. Okay, depending on which mode they want you, whether they want you to do in radians or degrees. Okay. Okay. Okay, and then in 7.7, you are going to be asked if it's parallel, orthogonal, or neither. Okay, so orthogonal is actually just a fancy word for perpendicular. So you can think about it as, except it's 3D. So orthogonal is just essentially saying that if I have two vectors, I have like one going here and one going here, right? And they essentially make a 90-degree angle. So that's why v dot w is equal to 0. Because if you think about it, if cosine of theta is equal to 0, right, that will make it 90 degrees. Okay, so orthogonal would be if v dot w is 0, and then parallel if cosine theta is equal to 1 or -1. Let me just rewrite it here. Okay. So let me do an example. Let's just do number 2 here for the following, okay? So we are still going to use the cosine theta equals v dot w over magnitude of v, magnitude of w, okay? So v dot w, square root of 3 times 1 plus negative 1 times 1. So I have square root of 3 minus 1. Now this doesn't simplify, so I'll just leave it alone. Okay, magnitude of v. Magnitude of w. Oh, whoops, my apologies. I misread magnitude of v. So, sorry, let me do that again. Square root of 3 square minus 1 square. Sorry, negative 1 will be here. Square root of 3 plus 1 equals 2. So this is what I have, okay? So I'll throw this part in my calculator, right? I have cosine theta and then take the cosine inverse of your answer. Okay, notice we got 58.82, okay? Obviously, and then we can also tell already, right? Square root of 3 minus 1 over 2 square root of 2 is definitely not going to be 0 or 1, okay? But notice my theta is 58.8 degrees, okay? So obviously it is neither, okay? Right, if it's parallel, this will mean my theta is equal to 0, right, or 180. And then this one here, my orthogonal theta will equal to 90 or pi over 2. Okay. Okay. So let's look at this one here. Let's just do a couple more examples. Yeah, all you have to do is just kind of follow this, okay? Formula for the following. Okay. Now your result is you're actually going to have two vectors. Okay, so obviously your vector should be obviously something I plus something j. Okay, so if you're doing projection of v onto w, right, we'll just have to follow this formula. Okay, so you're essentially doing a dot product and then over the magnitude square, and then you're projecting it onto the original. Okay, so let's look at this here. So this is what I'm going to do. So v dot w, right, I can see is 2 times 1 plus -3 times -1 equals to 5. So W is equal to square root. If I do the magnitude of W, this is square root of 1 square plus -1 square, which is square root of 2. And I have square root of 2 square. And I'm projecting this over 1i minus 1j. So the idea is, what's happening is, right, this 5 over 2 essentially is a scalar projection. And I'm projecting this onto my original vector. So v1 is going to be 5 halves I minus 5 halves j. Okay, so that's my first vector here. Okay, and then v2, all I do is take my v, and I'm going to do, right, I'm going to take my v and subtract my v1 from it. So what's going to happen is it's going to look like this. So it's going to be 2i minus 5 halves j. Okay, and then plus -3j minus 5 halves j. So 2 minus 5 halves j is equal to -1/2. Sorry, I, my bad, not j, is going to be equal to -1/2 I. And then I have -3 minus, oh, be careful, sorry, I have a double negative, my bad. So this will be plus 1/2 j, right, because I have a double negative, right, -3 plus 5 halves. Oh wait, sorry, this is minus, my bad. Yeah, sorry, because it's -6 halves plus 5 halves. Sorry about that. Okay, so that will be my second vector. Okay. Now here's the thing, okay? You can check by doing the following, because it says v2 is parallel to w and v1 is parallel to w, my bad, and v2 is orthogonal to w. So if I do dot product, right, if I do v2 dot w, it should be equal to 0. So if I do dot product, I have -1/2 times 1, and then plus -1 times -1/2. So I have -1/2 plus 1/2, and that equals 0, which is good, okay, which means it's orthogonal. And then if it's parallel, right, that means if they're parallel, we want to show, if you guys remember back up here, that cosine of theta is equal to 1. So if I do the angle between two vectors, I can do cosine theta of v1 dot w all over my magnitude. It should equal to 1, okay? So let's take a look at this. v1 dot w here. I have 5 halves times 1, and then -5 halves times -1. my magnitude for V is equal to 2 square plus negative 3 square. Oh, sorry, whoops, V1, my bad, not V. So 5 halves square plus 5 halves square. Square root of 50 over 4. Or this is 25 times 2. 5 square root of 2 over 2. And then magnitude of W equals square root of 2. Okay. So this looks a little sloppy here, but let's take a look at here. So I have 5 halves plus 5 halves. And this is 5 times 2 over 2. This is 10 over 2 divided by 5, or 5 divided by 5, and that's 1, so we're good. Okay. So this is what we're going to have here. Okay, so this last one order of business I want to talk about in 7.7 is talking about the concept of work, okay? The formula is actually not that difficult, but sometimes it can be hard to conceptualize for the following. We want to kind of draw this out. Okay, so work essentially is force times distance, okay? And right, so normally that seems pretty straightforward. The thing we have to be really careful about is we have to think about the total distance in regards with x, okay? So it says a wagon's being pulled along the level ground by exerting a force of 25, right? So here's your wagon. And it says on a handle that is 38 degrees, right? So this is your handle here. And it's 38 degrees. And so someone's pulling it, and they're kind of pulling it up, right? They're not necessarily pulling it straight, okay? So your formula is W is equal to F times, right, whatever your distance is, which is from A to B. Now, the thing we have to be really careful about is now my force is pretty straightforward. That's 25 pounds. And yes, I am pulling it 100 feet, but that's only partially the truth because I'm pulling it at an angle. So the way I want to think about this is I'm actually multiplying this by 100, but it's cosine of 38. Okay, so I'll throw this in my calculator. Be careful, make sure you are in degrees, not radians. And we are, so we're good. So I'll do 25 times 100 cosine of 38. Okay, and so we get the following here. My answer is going to be the following. It's going to be 1970 foot-pounds. And that is my answer. Okay. Okay. So let's take a look at the next one. Okay, so let's look at one last one. It says the force of 60 pounds on a rope is used to pull up a ramp at 12 degrees from the horizontal. Figure shows a rope forms an angle at 38. How much work is being done when the box is 20 feet along the ramp? Okay, so idea is we have a ramp here, and we have a box. Actually, let me draw that because that angle is too steep, because it says my ramp is at 12 degrees. So it's probably a very narrow ramp. So 12 degrees here, and I have a box. Now notice when I am pulling the box, it is at 38 degrees to the horizontal, right? So my horizontal is here, but I'm pulling up at 38 degrees. Okay? So force is work is, my bad, force times the distance. So your force is pretty straightforward. It's 60. Your distance is 20. Now, what is your angle going to be? Okay. So we are pulling up, or the person's pulling up at 38 degrees. However, they are on a 12-degree ramp. So your cosine is actually not 38 degrees because there's a 12-degree ramp that's kind of taking up the difference. So you're going to do 38 minus 12. So 60 times 20, cosine of 16. Okay. And we get the following here. Or sorry, 26. Wow, my bad. 38 minus 12 is 26. And so my work is 1,078.55. And we can say foot-pounds as our answer. Okay. So that's pretty much it. If you have questions, let me know. Okay. Yeah. Or you can send me an email. Okay. Hope you guys have a good day. I'll talk to you guys later.